Hi, Adriana. Here's the second part for your question that you're asking me for number two. Unfortunately, I'm having trouble getting back onto my Trent. I think maybe the email server is down for a minute or two, so I haven't got the question here in front of me, but I do recall what it was, and it's slightly different than the one that I gave you for number one. The one that I was working on for you for number one. It looks exactly the same, but there's a little bit of a difference because I think what they give you is that the probability density function, I think they tell you that it's f of x equals cx. And I think what they want you to do here is going to be just slightly different than what we did in the other one, because we just took the probability ourselves, which was 1/8, and we worked from there and took the integral. Here what we have to do is we have to integrate cx dx over the interval to 10. So same interval, but different function, because if we integrate this function, then the integral of x is x squared, and because the new exponent is 2, that means that we also have to divide by 2, and then it's going to be plus c, and it's going to be over the interval 2 to 10. So that plus c will go away now when we actually make this a definite integral, when we put in the 10 and the 2, okay? So what happens here is if I substitute in the 10, I'm going to get 10 squared times c over 2 for the 10, minus, and if I put the 2 in now, I'm going to get 2 squared times c over 2. And that leaves me with 100c over 2 minus 4c over 2, or 50c minus 2c, which is 48c. Okay. So here's where it gets interesting, because we go back to what we were talking about before with the idea that for a probability density function, that the area under the curve is always 1. In other words, the sum of all the probabilities always has to add up to 1, and that makes sense, right? If you have a sample space with all the possible outcomes, then all of those probabilities of each of those outcomes occurring has to add up to 1, because there's nothing else that can happen. So what we know is that 48c equals 1, so that means c is equal to 1 over 48. So now we have our probability density function, which is going to be 1 over 48x squared. And you can use that function now to solve for the other probabilities exactly the same way that we did for number one. So if it's probability, I think it was of x being greater than 5, then you're going to evaluate this. Sorry, let me move this up again. You're going to evaluate for px, I think it's greater than 5, but again, I don't have it in front of me. If it's greater than 5, then you're going to evaluate this function over 5, 10. If it was less than 5, you would evaluate it over 2, 5, because it would be all the values from 2 up to 5, and so on. And so everything works exactly the same way. It's just that you're dealing with a different function this time than we had in question 1. And I think you should be able now to plug in those values that they're asking for. And if you can't, then email me back and I'll check a little bit later to see if you need more help with it. Okay, thanks.